Hello students. So today we will learn some more types of integrals. Okay. So today's type is integral which has both the functions numerator and denominator trigonometric. Okay. So trigonometric function over trigonometric function. Now this type of functions will be given with different angles. Okay, so you have to adjust the angles so that you can solve them. Okay. Let's see some examples. So if it is given cos 4x upon sin 2x dx. Okay. So now here the angle is 4x and here the angle is 2x. So you have to make them equal. Okay. So you can make use of the trigonometric identities which you have learned in your 11th standard. Okay, cos 4x you can write it as 1 minus 2 sin square 2x, right? Because cos 2x is what? 1 minus 2 sin square x. Okay, so you can so the angle is doubled, so you have to double the angle. That is, if here it is 4, then this will be 2. Okay, so I'm going to write here integral 1 minus 2 sin square 2x upon sin 2x dx. Okay, now separate the denominator. So 1 upon sin 2x minus 2 sin square 2x upon sin 2x dx. Okay, so one of the sin 2x gets cancelled, so you will get here 1 upon sin 2x is nothing but cosec 2x minus this will be 2 sin 2x, okay, dx. Now you have to integrate. So while integrating cosec 2x, integral of cosec 2x, I will write here. So integral of cosec 2x is log cosec 2x minus cot 2x and the derivative of 2x, which is 2 in the denominator, okay, minus 2 sin 2x. 2 is the constant. Sin 2x integral of sin 2x is minus cos 2x and the derivative integral of sin 2x is minus cos 2x and derivative of 2x come in the denominator plus c. So the final answer will be log cosec 2x minus cot 2x upon 2 plus, we'll write here only, minus and minus, you will get here plus, okay, plus c. So this will be your final answer. Let's see one more. So here another example. So here sin x plus 4 upon sin 2x is given. Okay, so sin x, either you have to convert sin x or sin 2x. Okay, so let's write this sin x as sin x only upon sin 2x. You can write it as 2 sin x into cos x, that is our trigonometric identity, plus 4 upon sin 2x dx. Okay, so this and this gets cancelled, so you will get here 1 upon 2 cos x, right? So half is here and 1 upon cos x is sec of x, okay, plus 4 upon sin 2x, you can write 4 cosec 2x dx. Okay, So half you can take outside. What is the integral of sec of x? Log of sec of x plus tan of x, correct? Plus 4 integral of cosec 2x is log of cosec 2x minus cot 2x and derivative of 2x, which is 2, plus c. Okay, so this 2 and this 4 gets cancelled, so you will get here 2. This is the answer. Plus c you have to write. Okay, let's see one more type of integral. Okay, here there is a quadratic equation in the denominator. Okay, this you can write it as some px square plus qx plus r. Okay, this type of integrals you can solve by using the standard results, okay, which we have done. That is 1 upon x square minus a square, then 1 upon a square minus x square, and 1 upon x square plus a square. Okay, so let's see one example. Integral dx upon x square plus 4x plus 4. Okay, now you have to write this quadratic equation in the form a plus b the whole square. Okay, can you write this a in the form a plus b the whole square? Okay, so this is what your x square plus 2 into 2x plus 4 is 2 square. Okay, it is already in this form, that is x plus 2 the whole square. Okay, this is direct. So write dx equal to x plus 2 the whole square. Okay, this you can directly integrate, that is this is nothing but x plus 2 raised to minus 2 dx, right? So the integration is x plus 2 raised to minus 2 plus 1 upon minus 2 plus 1, and the derivative will get here multiplied in the denominator. Derivative of x plus 2 is 1. Okay, plus c. So this is nothing but minus 2 plus 1 is minus 1 into x plus 2 raised to minus 1, which you can write in the denominator. So this will be minus 1 upon x plus 2 plus c. Okay, this is the answer. Let's solve this. So this is x square plus 8x plus 20. Okay, so you have to write it in the form a plus b the whole square. Okay, so I will write here x square plus 8x is you can write it as 2 into 4, right? And the last term will be, if you have to write it as x plus something the whole square, this is your 2, this is your a, and this is your b, right? So b square, 4 square, which is 16. Okay, so I can write this term as plus 16. Okay, and our original 20 is there, and one more term, that is if you have added here plus 16, then you have to minus here minus 16. Okay, so this is the adjustment you have to do. Now this is your a plus b the whole square. Okay, let's solve. So integral dx, this will be what? X plus 4 the whole square. After expanding, you will get this, and this is 20 minus 16, so this is 4, right? So 4 you can write it as 2 square. Okay, so this is in the form standard result, that is 1 upon x square plus a square. Okay, that formula you have to use. So this will be 1 upon 2 tan inverse x plus 4, right? So 1 upon x square plus a square is 1 upon a tan inverse x by a plus c. So same this formula, this standard result you have to apply here. So this is your x and this is your a. Okay, so this will be 1 upon a is your 2, tan inverse x is x plus 4 upon a is 2 plus c. Okay, so this is the answer. Let's solve this. So this is x square minus 6x minus 7. Okay, so you have to write it in the form a plus b the whole square. Now here minus sign is there, so this will be in the form a minus b the whole square. Okay, so write x square minus 6x. 6x you can write it as 2 into 3, right? So this is your 2, this is your a, and this is your b. A, b, and this is 2, 2ab, right? So b is 3, so you have to add here 3 square, which is 9. So you can make here adjustment, that is plus 9 minus 7, and here you have added plus 9, so you have to subtract 9. Okay, so this is your a plus b the whole square. Okay, so let's write it in that form. So this will be x minus 3 the whole square. Okay, and this is your minus 7 minus 9, which is minus 16, and 16 is square of 4, so you have to write here 4 square. Okay, so this is in the form integral dx x square minus a square. So formula for this is 1 upon 2a log x minus a upon x plus a plus c. So we'll apply that standard result. So 1 upon 2a, 2a is 4, so 2 into 4. Okay, log of x minus a, x is your x minus 3 minus a, which is 4, and this is x minus 3 plus 4 plus c. Okay, so x minus 3 minus 4 is minus 7, and minus 3 plus 4 is 1, and 2 4s are 8. So this is your final answer. Let's solve this. So this is given 4 minus 2x minus x square. So this I can write it as integral dx 4 minus, I will take this minus sign outside, so this will be x square plus 2x, correct? Okay, now I have to adjust the terms. So 4 I can write it as 2 square minus, this will be what, x square plus, this is 2x, right? 2ab, so 2x is there and b is our 1, so you have to add 1 so that it becomes 1 square. Okay, so x square plus 2x plus 1. So while writing here, I am writing here plus 1. So if I take this minus sign inside, what it will be? Wait, so I will just write this again with the minus sign. This will be like this, right? So you are subtracting 1 and you are adding 1 to this whole equation. So you have to add here 1. Okay, there is a chance that you may make a mistake here, because there is a negative sign outside, and if you take here positive, So you will take 1 as negative. Okay, so you have to see if this 1 gets a negative sign, then you have to take this additional 1 as a positive one, so that they get cancelled when you take the terms in the bracket outside. Okay, they should get cancelled, and you should get the original term, that is 4 minus 2x minus xy, because we are making the adjustments, right? So this, okay, so this we can't write it as 2 square, so you have to write it as 4 only. So now we'll write dx upon 4 plus 1 is 5, plus this will be x plus 1 the whole square. Okay, this is minus. Okay, so 5 you can write it as root 5 the whole square, correct? This is the same thing. 5 you can write it as root 5 the whole square. Now this is in the form integral dx upon a square minus x square. So you can write it as 1 upon 2a log a plus x upon a minus x plus c. Okay, so apply that standard result. So your a is root 5. So 2 into root 5 log a plus x. A is root 5 plus x is your x plus 1. Okay, upon root 5 minus x plus 1. Please write these terms in the bracket. Okay, because there is a minus sign over here. Plus c. So this is the answer. Let's solve this. So here it is given 5x square minus 6x minus 8. But to write it in the quadratic form, that is to write it in the a plus b the whole square form, I want here x square, not 5x square. So I have to remove this 5. Okay, so you have to multiply and divide by 5. So this I will write it as 1 upon 5. So this will be 6 upon, here also it will be 5, it will be 5, here it will be 5, right? So this and this 5 gets cancelled, and you will get here x square. Okay, now you have to make the adjustments. Okay, so this will be what? X square minus 6 upon 5x. So this you can write it as 2 into 3 by 5x, right? So this term will be 2ab, and b square you have to take, that is 9 upon 25. So this term you have to add and subtract to this term. Okay, so I will write here plus 9 by 25 minus 8 by 5 and minus 9 by 25. Okay, I'll just rub this. So this is your a plus b the whole square. 1 by 5 is a constant term, you can take it outside. So dx upon, this will be x minus 3 by 5 the whole square, and this you have to do cross multiplication. So this will be 5 into 5 to 5. This will be 40 plus 9, so 49 upon 25. Okay, that you can write it as, this is 7 squares and this is 5 squares, so 7 by 5 the whole square. Okay, so this is in the form x square minus a square. So apply that result. 1 by 5 is outside. 1 upon 2a, a is your 7 by 5 log of x minus a. So x minus a, x minus 3 by 5 minus 7 by 5 upon x minus 3 by 5 plus 7 by 5 plus c. Okay, so here you can write it as 1 upon 5. This will be 5 upon 14 log x So you can cross multiply this minus 10 upon 5, and this will be x plus 4 by 5 plus c. So this is the final answer. Okay.